let's look at an example of constructing a DFA related to the material in Sipser section 1.1, which is roughly pages 31 through 40 in the 3rd edition. So the language that we're looking at is L, which is a set of strings W, such that W has length 4. Okay, so remember L is a language, therefore it's a set of strings. Here the strings are represented by W, and W has the condition that W has length 4. So we're looking for all strings W that have length 4. Okay? So what we want to do is we want to build a DFA for L. So what we're looking for is we want a DFA M equals, and remember it's going to be a 5-tuple Q sigma delta Q0, or the start state, and F, the set of final or acceptance states. And what we want is to build M so that the language of M is L. Or we want M to recognize the language L. Okay, so first we need to define sigma. So we need to know what our alphabet is that that strings from this language are going to be constructed using. So here we're going to have sigma be A and B. So sigma is a set of symbols A and B. Okay. Now let's think about some strings that are in L. So we're thinking about some strings that M should accept. So these are going to be strings of length 4 that consist of characters A and B. So some strings, so M should accept, okay, strings like A, or B, or A, B, or A, B, A, or B, A. Okay, these are 5 examples. There are many more strings that M should accept. Let's get some examples of strings that M should not accept. So M should reject strings that are not in L. So notice that the defining characteristic here is the length of the string. So M should reject strings that are not length 4. So it should reject that string, A. It should reject the string B. It should reject AB. It should reject BBA. It should reject ABA, and it should reject BBB. Okay, again, there are many more strings that M should reject. We're just coming up with examples to think about how to build this machine M. Okay, so what we're noticing here is the idea is that we need to remember that we've seen 4 symbols. That's what we need to know. So in all of the strings that M should accept, up here, they all have 4 symbols. Whereas here, if I have fewer than 4 or more than 4, M should reject. Okay, so with that knowledge, let's try to build M. Alright, so we need a start state. Let's call it Q0. Okay, and then we need to keep track of seeing at least 4 symbols. So let's make some additional states to keep track of this. Okay, let's start with these states. Okay, so if we see either an A or a B when the machine starts up, then we want to say we've seen 1 symbol. So here, state Q1 is going to be the state that represents having seen 1 symbol. Now, if we're in state Q1 and we see another symbol, either an A or a B, we want to keep track that we've now seen 2 symbols. So Q2 says I've seen 2 symbols. And then if we see 3 symbols, if I see a third symbol, A or B, I want to move to state Q3. This is going to say I've seen a third symbol. And then if we see another A or a B, I want to go to Q4, and this is saying I've now seen 4 successive symbols. Okay, and if that happens, I want to be able to go ahead and accept. So let's make this an acceptance or final state. Okay, so let's try some of these strings that we had before. Okay, so let's try an acceptance string. Let's try ABAB. Okay, so if I see an A, I'm going to go from Q0 to Q1, and then I see a B while I'm in Q1, I'm going to go to Q2. Now I see an A while I'm in Q2, so I go to Q3, and then I see a B while I'm in Q3, so I go to Q4. Now I'm in state Q4, and I've run out of characters to read, so I stop, and I'm in a final state, so I accept. Okay, let's look at another string. Let's look at BBBBB. Okay, 5 B's. If I read the first B, starting in state Q0, I go to Q1. Then I read another B, I go to Q2. I read another B, I go to Q3. I read another B, I go to Q4. Now I need to read another B. But you notice I don't have any transitions left to take. And actually, this is because what we have here is not actually a DFA. It's missing something. I need to know what transitions I should make if I'm in state Q4 and I see a B, or if I see an A, I need to know what to do. Well, since we know that any string longer than 4 characters should not be accepted by the machine M, then we need to be able to go to a state that won't allow us to ever accept. Okay? So what I mean is, if I keep going, let's make a new state called Q5. Okay. So if I see an A or a B, I'm going to go to Q5. And then, so this means I've seen 5 symbols. Once I've seen 5 symbols, I can never accept, right? Anything bigger than 4, I can't accept. So let's just stay here on any additional symbols. Okay, in this case, Q5 is a trap state. I can never get out of Q5, or it's a dead state. Okay, so this means if I read 10 symbols, I'm going to end up in Q5. If I read 50 symbols, I'm going to end up in Q5. Since none of these have length 4, and I will never get to length 4 again once I've passed length 4, I want to stay in Q5 and just keep looping until I get to the end of the string. Okay? It's important to notice what we did here. Instead of saying, okay, well, once I get to Q4, maybe we say, what if I just stay here? Okay, this is not going to be correct, because if I were to read that same string, B, 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 we said this is not length 4, this is length 5, so this should not be able to accept. Well, what happens? I start in Q0, and then I read my first B, I end up in Q1. I read my second B, I transition to Q2. Third B, I end up in Q3. Fourth B, I'd end up in Q4. And then if we had this loop here on Q4 instead of the one on Q5, when I read this 5th B, I would loop again and stay in Q4, and I'd accept. Okay? And so I'd end up accepting something that I should not accept. All right? So that's why we cannot have this loop here. Alright, so now our machine accepts this language L. It's going to accept whenever I have strings of length 4, and if I have strings that are less than length 4 or more than length 4, it's going to reject. Okay, so let's match this to our formal definition. Remember we said that M is a 5-tuple, so this is M here, our machine M. So let's figure out what our formal definition is. So Q is the set of states, okay, and that's going to be the set Q0, Q1, Q2, Q3, Q4, and Q5. So that's my set of states Q. We already said that sigma, our input alphabet, is the symbols A and B. I'm going to skip delta for a minute. We have Q0, our start state. That was what we named our start state. And then F, our set of final states. It has to be a subset of Q, and in this case our only final or except state, same thing, different name, is Q4. Okay, so now we need to define what delta is. So I'm going to go to a different screen so I have some more room. Alright, so there's a couple ways that we can write delta. We can write it in function notation, or we can write it as a table. So let's write it as a table first. So here's my table. And I need to know what state I started in, and then what symbols I'm going to possibly read. So here I'm saying if I started in Q0 and I read an A, where do I go? Well, we went to Q1. The same was true for reading a B. I went to Q1. If I'm in Q1 and I read an A, I'm going to go to Q2, and if I read a B, I'm going to go to Q2. If I'm in Q2 and I read an A, Q3. If I read a B, Q3. If I'm in Q3 and I read an A, I'm going to go to Q4, and if I read a B, I go to Q4. If I'm in Q4 and I read an A, I go to Q5. If I read a B, I go to Q5. If I'm in Q5 and I read an A, I'm going to stay in Q5. This was that trap state we created. And if I read a B, I'm going to stay in Q5. Okay, this is a really good way, this table is a very good way to check to make sure that you have exactly one transition out of every state on each of your symbols. Okay, because if I had a blank spot here, that would tell me that I was missing a transition. And if I tried to put an additional state, let's say I tried to say, oh, okay, we also go to Q4. This is a problem, right? I'm not allowed to do that. So this table would tell me. Okay? The other notation that we sometimes see looks like this. And so we say delta, and then we're going to list a state and then an input symbol. So let's give the state Q0 and the symbol A. This is saying, what's my transition if I'm in state Q0 and I read an A? Well, we know from our table, we're going to go to Q1. Or we could also look at our diagram and see where our transition went. Okay, and the same is going to be true for B. Okay, since they both go to the same place, I'm just going to do the rest of the transitions for A. So if I was in Q1 and I read an A, then I would have had to go to Q2. If I was in Q2 and I read an A, I go to Q3. If I'm in Q3 and I read an A, I go to Q4. If I'm in Q4 and I read an A, I go to Q5. And if I'm in Q5 and I read an A, I stay in Q5. Okay, so these are the two different ways to write out our transition function. Just make sure that for each one of these that we had the A symbol. So for each one of these, you also have the transition that shows what happens if you read B. Okay? All right. So since we've now defined M in terms of, so on the other page we gave Q, we gave sigma, we've given delta. Q0 is the name of our start state, and we also defined F on the other page. Then we have a full formal definition for our machine M, and we also showed that M accepts the language L. So we did what we set out to do. For some of you, your class is going to require that you use JFlap. So we're also going to go ahead and show how to, let me get out of here. Bear with me for a moment. Yes. All right. We're also going to go ahead and create this DFA in JFlap. All right. So I'm not going to do this for every example, but I'm going to do this for at least a couple. All right. So we need to go ahead and make our states. So I'm going to select the button that is my state creator button, and let me list. We had we had 6 states, right? Yeah, we had these states. So I've got my states. I'm going to set up my start state, Q0. Maybe I can get these to be better in line. So we have a little more room. All right. We also said that Q4 was our final state, or our accept state. So I'm going to make Q4 an accept state. And now I need to put in my transitions. So I'm going to go to the transition button, and I'm going to draw my transitions. So this is on A or B, and there's my transition from Q0 to Q1. And again, on A or B, I can transition from Q1 to Q2. Oh, that one went a little wonky, huh? Oh, whoops. All right, so this is a good time for me to show you what happens if you mess up. Okay. Let's just put something in there. Let's see. So that it'll let me get out of here. All right. So I drew a loop where I didn't intend to. So I used this skull and crossbones deleter button, and I just need to click on it, and it'll get rid of it. Good. All right. So now let's make another transition. This was on A, B. And then finally we said that Q5 was a trap state or a dead state where we can never get out of it. So I just click right on the state itself instead of dragging between the states, and this gives me a loop. Okay? So this should look like what we created for M. So here is our automaton M. So now let's try checking some of these input strings that we had. So I don't remember which ones we did on the slide. Let's choose 5 that we know we should accept. So we should accept AAAA, and we should accept BBB. Oops. There we go. BBBB, and then we should accept ABAB. Okay, we should also accept ABBB, and we should accept BAAB. Okay, so there's 5 example strings that we should accept, and let's do 5 example strings that we should reject. So let's do A. Let's do BA. Let's do ABB. Let's do AAAAA. And let's do ABABAB. Okay. So I'm going to click Run Inputs. Uh-oh. Okay, so we had a slight technical difficulty. So what I did wrong is I tried to put 2 symbols on the same arrow, and in JFlap you have to do separate transitions per symbol. So here's A, and let me add another one, B. Okay, and then it does it for me. So let me get rid of these transitions. Okay, and let's just redo those transitions. Whoops. Alright, so this should be better. This should fix the problem. So I'm going to go again to input, multiple run, and then here are the strings that we want to test. And I'm going to click run in inputs. There we go. That's what we wanted to see. So the samples that we expected to accept do in fact accept, and the samples that we expected to reject do in fact reject. So this is good. Okay. So if I needed to go back to my editor, what I would do is say File, Dismiss Tab, and this takes me back to the editor. Okay, so that's the end of this example.